Hi, I'm Jacob McGregor, and today I'll be walking you through my Lab9, which is an alarm system. And instead of using sound, it opens up the blinds and lets light in. So really quick, you can see I have a little LCD display with the current time, the alarm time, the date, and a little Bible verse. And what you'll see is that when that alarm time hits, this system is going to actuate, and I'll zoom out a little, and it'll start initializing the stepper motor. And so the processing code pops up with the good morning. The stepper motor begins to spin and adjust the angle of the blinds, which should be a little more obvious in a few seconds. And so it lets max light into my room. So this is great for waking up. And really quick to walk you through my circuit, we have the H bridge back here, which powers the stepper motor. And really quick, the processing code goes back to waiting after 30 seconds. But you have the stepper motor powered by the H bridge, and then those are my two 3D printed parts. I have a little coupler for the motor and the wand, and then I also have a little support piece for the stepper motor. I also have this real-time clock, which allows this to act as a functional alarm system, even without being like tied to the computer. And then I have this LCD display, which acts as sort of its own processing. So if I go to sleep, I'll close my laptop, I can still have sort of a functioning alarm clock. So it's not really that useful for this project, but outside of this project, like using this outside of the grading purposes is helpful. I also have this photoresistor here, which is wired in a voltage divider for max resistivity. It has a nominal resistance of 15 kilo ohms, and so that's what I got through this little series of resistors. So as you can see, the time is now 9:28, and the alarm time changed because it went past the other alarm time. And we should see this in just 1 second. Oh. So this pops up with good night. And you can see the motor start to spin again. And so you can also see here that the state is constantly updating, which is how the processing actually displays. And then it'll also display here in a second what the current light level is, what the previous light level is, and then it'll continue to adjust for that. So you can see here, it had a previous light level of 746 when it started. And when I say when it started, I mean after the initial 2.5 rotations. Then it dropped down to 682. It spun 45 degrees again, and then it dropped down to 675, and then it did it one more time, and it stayed at 675, so then it stopped and it waited for a minute to get out of the code. And so essentially why it does that is it's calibrating it so when the motor starts to stall, when it's fully twisted, like no matter how much you twist this one right now, these are at their max angle. So when that begins to stall, the photoresistor senses it by detecting that there's no light changes, and that allows the motor to stop when it's fully closed. And really quick, this is the last thing I'll talk to you about is this is the code for what I was just talking about. It initially is going to spin 2.5 rotations converted into steps. And then it's going to go through and compare the previous light level to the current light level. And it's going to test if they're within the tolerances. And then if it is, it's going to break out. And if it's not, it's going to continue running through this cycle of rotating. And then one other thing I did too was I had moving averages instead of just taking one point to reduce noise. And so this is the code for that too.